Hi class, so we are going to be doing the first page of quiz 7, and that's about systems. I know we've already talked about systems before, but that was when we only talked about lines. Now that we've seen parabolas and absolute values, we're going to bring those functions together with systems to see the type of answers answers we're supposed to get. Now, I already went through this and the video didn't load, which is why the page is already filled. Just bear with me. When we talked about lines and lines, we did that way back in the beginning of the year, so I have two lines. And if I want to see where a solution to that system is, I see where they intersect. Now I could have two parallel lines, like so, and they will never intersect, which is why I put a possible answer, a possible solution to our system is 0. We could also take our two lines and cross them like so, and we notice that they do cross at one point, and that's why we put 1 here. And infinite solutions is possible when I take the two lines and I overlap them and they turn out to be the same exact line. They have solutions everywhere. So we have infinite solutions because they cross everywhere. We have that. This is the visual representation you could fill out and help yourself go through everything. Now we're going to talk about lines and parabolas because we just finished talking and learning about parabolas. So if I take our line and I take a parabola, I could have a system that looks like this when I graph it. Now notice they'll never intersect, which means 0 is a possible answer for our system. I could have a system with a parabola and a line where they cross just at the tip. So the vertex is intersecting at one point of our line, and that's when we can get one solution. And we could also just further bring it down, and I know it's hard to see, but they overlap and they cross each other in two places. And that's why we can have two solutions to a system where there's a line and a parabola. Now I can't have infinite because there's no possible way where a line can go on top of a parabola for every single point possible, which means there's no infinite solutions possible. There's no solution possible, there's one solution and two solutions possible, but that's it. All right. Next, we're going to look at absolute, oops, you can't see the word, absolute values in lines, and we talked about that before the quadratics unit. So I could have an absolute value like so, and a line like this, and they'll never cross. So we're starting to see a pattern of no solution for that one as a possibility. Another possibility is, well, what if I bring it up just enough where my line hits the vertex only of my absolute value? That's going to be one solution. But if I keep bringing it up, notice how I will intersect it in two places. So I'll have two solutions. And as I go through, I want you guys to fill in the rest of the visual representations. Those are kind of what I'm doing with our cutouts. Okay. Next, even though we haven't learned about circles per se, you've kind of seen them in geometry, and we're going to apply our knowledge to systems with graphs to help us figure this out. Now if I have a circle and I have a line, I can put them as so, and just like all the others, there is a possibility where they'll never cross, which is 0. I could bring my line up just a tad where it only touches one spot of my circle, so we can have one solution. Or if I just bring it further, we can have two solutions, which means for circles, we can have 0 solutions, no solutions, right? One solution or two solutions. And that's it. We're going to move on to our next row. Let's cover this. Of parabolas and lines. We've already done, right? So we're just going to copy our answers. Boom. Right here. So we have already filled this out technically, and there's no point in repeating ourselves. Next up though, this is a new one. We have a parabola and a parabola. So if I have a system of two parabolas, let's see how many solutions, how many intersections we can get. So I could have one parabola look like this, And I could have another parabola look like, oops, you guys can't really see it that well, like so. And we notice they'll never cross. So just like all the others, we could have 0 solutions. I could kind of fold them, bring it a little higher where only my vertexes touch, and that leads us to 1 solution. Or if I bring it up further, you can see we have 1 solution here and another here. That leads us to 2 solutions. And just like line and line, what if I flipped it and I tried to see what happens now? Okay, I haven't intersected yet, I haven't intersected yet, but look, now the parabola is on top of the other parabola in every single possible way, and we can have infinite solutions when we have a parabola, and we can have infinite solutions when we have a line and a line in our system. Okay. Next up, we have an absolute value and a parabola. Let's see if we can figure out what happens here. We have a picture like so, no solution. Again, I can bring things down to where only the vertexes touch, 1 solution. Or we could have 2 solutions. And just for fun, let me see what happens if we make them both face down. Okay. I can go here. Oh, and if the vertex touches, and then I have 2 other points that can touch, which means I can have 3 solutions now as well. And if I go even further down, right, I can have 1, 2, 3, 4 solutions. You can't really see the parabola all that well, so I'm going to draw it in. So we could have a parabola intersect it like so, and we're going to have 1, 2, 3, 4 solutions. So in my last video I forgot to include 4. So we could have no solutions, 1 solution, 2 solutions, 3 or 4 possible solutions. All right, next up we have a circle with a parabola. All right, start off like all the others, we can have no solution. I can slowly bring it up and see my vertex can touch 1 point of the circle and get 1 intersection. I could bring it up where the vertex is in the center of my circle and we intersect twice. Or if I keep going, I put the vertex here, that's 1 intersection, another intersection, and another intersection, because these go on forever. Parabolas go up or down to infinity, which means I can extend it and hit it 3 times. Or if I go just a little further up, I can intersect it at 1, 2, 3, and 4 points, which means I can have 2, 3, 4, 1, or no points of intersections or no solutions when it comes to parabolas and circles. Okay. The last row I'm going to do with you guys is absolute value. Absolute value in line we already did up here, so I just copied it. And we're going to talk about absolute values and parabolas, which we already did as again. So it's 2, 3, 1, 0, and 4. So it's 2, 3, 1, 0. Oops, I forgot that one as well. 4. The new one is absolute value with an absolute value. Right, let me find the 2 possible V's. Here we go. Could have an absolute value with an absolute value. I already drew the parabola, but ignore that one. I could have them never intersect. We could have the vertexes intersect and just like make a big giant X. I could go down like this and they'll intersect in 2 points. Or if I go up, since they're both absolute values, they can go on top of each other and intersect everywhere, which leads to infinite solutions. Notice how whenever the 2 things in our systems are the same, they have a possibility of having infinite solutions because you can now copy each other and put it one overlapping the other. Absolute value in circle is going to be very similar to parabola in circle, where we can have 0, 1, 2, right? 3 if I extend it, and then 1, 2, these go on forever, 3 and 4. That leads to 0, 1, 2, 3, and 4. Now the last one, I'm not going to fill out, but I'm going to have you guys do in class, which means when I see you next time, I am going to be checking to see if you fill in this table with all the diagrams and if you filled in the last row. Okay? You have no homework though, so enjoy your time. Have a great day.